So in section 2.3, we actually worked with a rule of replacement called transposition, okay? And it stated that if P implied Q, then not Q implied not P. This is also called the contrapositive, and that's how I did our last example proof. So, for example, if I read at the doctor's office, then I remembered to bring a book. So this is P implies Q. If I do not remember to bring a book, then I do not read. This is the example of the contrapositive, or what we called before in chapter 2, the transposition. So, in section 2.3, we worked with a rule of replacement called transposition, right? And we can also use the contrapositive for inequalities. So we can write the contrapositive of the following below. So what we're going to need to do is change our signs and change our and flip our signs. So if I have negative 3 is greater than or equal to 1, that means negative 3 is less than or equal to negative 1. If I have 2n is greater than n, I have that negative 2n is less than n. If I have negative 4 is less than 0, that means that a positive 4 is greater than 0. And if I have x is less than or equal to y, that means x is greater than or equal to y. Sorry, greater than y. When you flip it, you lose the equals sign. The method of indirect proof is also called proof by contradiction. In proof by a contradiction, we assume our premise is true and that our conclusion is false. We will then arrive at a contradiction proving our conclusion is true. So, if n is greater than 0 and 4 to the n minus 1 is prime, then n is odd. So let's assume n is even in order for us to do this indirect proof. Let n equal 2k, so it's an element of the even numbers. Then I also want to assume that 4 to the n is prime. We need to prove that if 4 to the n minus 1 is prime, then n is odd. So let's go ahead. If I've got 4 to the 2k minus 1, that's going to give me, remember I could factor this, right? If I had 4 squared minus 1, or something like x squared minus 1, this would factor to x plus 1 times x plus 1, again going back to college algebra. So this is going to give me 4k plus 1 times 4k to the k minus 1 is how this is going to factor. So therefore, it's not prime. So we proved at our contradiction, we arrive at a contradiction proving our conclusion is true, because if n was even, then it's not prime. So thus this is a proof by contradiction. Let's work through another proof of contradiction. So if AB is even, then either A or B is even. So let's assume that both A and B are odd. So let A equal 2n plus 1 and B equal 2m plus 1. I need to go ahead and multiply these two together. So I have AB equals 2n plus 1 times 2m plus 1. That's going to give me 4mn plus 2n plus 2n plus 1. So I could pull out a factor of 2 from this part. So this is going to be 2 times 2mn plus m plus n plus 1, which is odd because all numbers that are 2n plus 1 are elements of the odd numbers. So since the product of odd numbers is odd, AB is odd, thus if AB is even, then either A or B is even is our proof by contradiction. The last and best type of proof is a proof by counterexample, okay? When we're proving by counterexample, we can show something is not true by finding an instance when it is false. So prove the square root of n is rational for all n element of n. So I know the square root of 1 is 1, which is rational, but for example, let n equal 2, the square root of 2 is an irrational number because it can't be simplified anymore. Thus, the square root of n is not rational for all n element of n. So your homework is actually all of the problems in section 3.1. If you are having any questions over any of them, please let me know. I have lots of hints. I also have already made the keys. I'm going to continue to check your homework as they submit it. I'll be posting section 3.2 on induction later on this week.